simple population inference about the median of a population when my sample size is greater than 10. A manufacturer of iPad battery has established that the median time it takes for a battery to lose its charge is 10 hours. A sample of 40 iPad battery from a competitor is obtained, and the battery are tested continuously until each fails to hold a charge. Of the 40 failure times, 24 exceed 10 hours. If there evidence that the median failure time of the competitor product differ from 10 hours, use alpha 0.10. That is the problem in this equation. Our sample size here, our sample size is 40. Actually, this is greater than 30. Then when my sample size is greater than 30, NP and NQ, when P is equal 50% are greater than 15. That is the condition to use normal to approach binomial distribution. The table of binomial distribution, the maximum value for n is 20. And in this case, we need a table for 40. We don't have this table for 40. For that reason, we have to use technology, or we have to use normal to approach binomial. Then in this experiment, we use 40 iPad in the population of all iPad, the competitor, and we assume that the median of all of these iPad is 10 hours. Then if the median is 10 hours, all iPad, 50% of them the battery last less than 10 hours, and 50% the battery lasts more than 10 hours, because 10 hours is the median. Actually, the entire population, more than 10 hours, we have 50% of them that last more than 10 hours, and the other 50 less than 10 hours. But we took a sample of 40, and the distribution of all sample of size 40 follow this distribution. It's a binomial distribution. The sample is 40, the probability of success is 50%. Then the mean of the distribution will be n times p. In this case, p is equal 0.5 times n, and the standard deviation is given by n times p times q, because p is 0.5, q is the complement, also 0.5. This is 0.5 squared. We can take 0.5 outside the radical, and inside is less n. Then the mean is n times n, 0.5 times n, and the standard deviation is 0.5 times square root of n. If the sample size is n, then the mean should be equal 0.5 times 2 times 40 is 20. And suppose that 24 is here. That was the number of success that we obtained in my sample, 24 battery, like here. Then the probability that, if we want to compute the probability that 24 is bigger than the probability is we obtain a sample in which the number of iPad that exceeds 24 hours is 24 hours or more. We need to compute the probability for the 24, 25, 26 until 40. Because we can use normal to approach binomial, we need to transform this discrete distribution in continuous distribution. To do this, suppose that this value is 23 and this value is 25. To obtain the probability that one sample of size 40, 24 or more, the battery lasts more than 10 hours, in this distribution, we need to transform this discrete in continuous. To transform this in continuous, we must round all of these values to 24. Then all values between, in this continuous distribution, which is normal, all values between 23.5 and 24.5 could be round to 24 approximately. That is the way that we can transform this discrete distribution in continuous, given to all value between 23.5 and 24.5 the same probability for 24. Then how can we obtain the probability to obtain 24 or more values? Then the probability to obtain 24 or more values would be obtained using this formula. The probability to get a value, some S, number of success, greater or equal to 24 or equal to 24, we can obtain this probability exactly equal to 24, could be obtained using this procedure. It's equivalent using normal distribution. The probability to get a value, now let's put greater than or equal to 24. To obtain a value in a normal distribution, x greater or equal to, because 24 actually start in 23.5, greater than 23.5. Then if we want to obtain this area from 23.5 and up, then we compute this probability is equivalent, the probability that the C-score is greater or equal than 23.5 minus the mean, which is NP, divided by the standard deviation, which is 0.5 square root of n. That is the test statistic that we are going to use normal to approach binomial, because table doesn't exist for Foley. Then our null hypothesis is that the median is equal to 10 hours, and the alternative is the median is different, because that is the objective in this problem. Is there evidence that the median failure time of the comparator product differ? Then the alternative hypothesis is the median is different to 10 hours. Then because my sample size is greater than 10, we can use normal, we can use this formula to obtain probability of obtain area. Then our test statistic will be given by this 0.5. 0.5 is the correction for continuity, that is the median, and that is the standard deviation. And we need to substitute here 24 to obtain my test statistic. And we are going to compare this test statistic with my critical value. How can we obtain my critical value? My critical value, this is a total test, and alpha is given is 10%. We need to split this alpha in 0.5 to the right, 0.5 to the left, then 0.05 to the right. What is the critical value that corresponds to this area? Then this will be my reference point. We can find this value in the table, or we can use technology. If we use technology to find the corresponding C-score, because this is a C-score, the mean is 0 and the standard deviation is 1. We are going to put the values on the table using 0 and 1. Then we need to input this area to the right, because we need to select probability to get a value to the right, and we need to input this probability here in this box. And when we click compute, we obtain exactly our reference value. My reference value is 1.645, and my test statistic was 1.1. Then my test statistic fell in this area, no rejection region. It's close to my expectation. Then because my test statistic is 1.11, when we substitute 24 here, 24 minus 0.50 is 23.5 minus the mean divided by the standard deviation, my test statistic is 1.11. 1.11 is in this region, no rejection region. Actually, is a value that we expect in our distribution. Then for that reason, when we got a value close to my expectation, we failed to reject the assumption, and we failed to support the alternative. That is the reason in this case we failed to support the assumption that the median is equal to 10, and we failed to support the alternative that the median is different to 0.10 hours. That is our conclusion, and let's stop here.